In today's video, we'll be looking at what are operators in Go and the different type of operators that are supported by Go. So we have our well-known editor open. So let's get started. I'll create a file called operators.go, and as usual, create a package main. So what are the different operators that are supported in Go? One is arithmetic operators. This is the most well-known operators. I think the same are used in mathematics as well: addition, subtraction, multiplication, and division. And there's specific or a special operator called modulus or the remainder operator. Then we have our bitwise operators. We have logical operators, and we have relational operators. The last type is assignment operators. Now, what are these different kind of operators? Logical operators basically and, or, and not. These are the only three types. Relational operators are basically where you compare two different values like less than, greater than, equal to, not equal to, or less than equal to, or greater than or equal to, right? And bitwise operators are bit manipulations that you want to perform on basically binary data, that is and, or, XOR. Basically, or if you are familiar with gates, logical gates, these are your similar operators from gates. Then we have assignment operators. You must be familiar with an assignment operator, that is equal to. And then we have shorthand operators like plus equal to, then colon equal to, or maybe minus equal to, by equal to, sorry, by equal to, and equal to. These are some of the assignment operators. Now, how does each of these operators work? Let us see that. I'll create a function main and then import our formatting library for printing. Sorry, import fmt. Now, let's first try the arithmetic operators. Let's say we have a equal to 3 and b equal to 4. Now, make a note that this is also one of the operators, the assignment operator, and this is also used to declare and initialize variables in Go that we discussed in the previous video. Now, let's say I want to print the output of a plus b. This is your addition operator. Go run operators.go. Yeah, you can see the result is 7. So this was an example of the addition operator. Maybe you can try on your own the subtraction, multiplication, division operator. Meanwhile, I'll explain the modulus operator. What does it do? Now, modulus operator or the remainder operator is basically an operator that gives you the remainder after the operation. That is, for example, if you have a mod b, that is, once you divide a with b, what is the remainder? So 3 divided by 4 is basically it will go in fractions. So the remainder is 3. Maybe I can take a better example. Let's take 7 and 3. Now, if you divide 7 by 3, 3 is not a perfect divisor of 7. So 3 twos are 6, and the remainder, I mean, 7 minus 6 is 1. The remainder is 1. So a modulus b, your remainder is 1, and the output of a modulus b will be 1. So let's check it out. Yeah, you have 1. So that's your modulus operator. Now let's go to logical operators. Logical operators is basically and, or, and not. The logical operators work only on Boolean values. That means you need to have true or false values that we had covered in the previous video. False. Now fmt.println, a logical and is denoted by double ampersand b, and logical or is denoted by the parallel operator and not. Not is a unary operator. Unary means it takes only one operand. So in an expression that is a plus b, let's say c equal to a plus b, plus is the operator and a and b are the operands. C holds the result of the entire operation. So a plus b is the operation, plus is the operator, and a and b are the operands. So unary operators are basically which have only one operand. So not is a unary operator and it is represented using exclamatory mark. Now let's see if we can guess the outputs. A and B, that is A and B, true and false, should be false. True or false, sorry, should be true, and not of true should be false. Let's run the program to verify the outputs. As you can see here, we have gotten false, true, and false. So that's how logical operators work. So logical operators are basically used in conditionals. Mostly they will be used in conditionals to satisfy some conditional. So what are conditional operators and how conditions or control flow can be achieved in a Go program? We'll be seeing that in a later video. Now let's move on to the relational operators. Relational operators, as the name suggests, it gives a relation between the two operands. Again, relational operators are all binary operators. Basically, they take two operands, just like I mentioned a while ago. So let's try it out. Again, I'll take a equal to 4 and b equal to 5. Now, in this case, let's say I print ln, and the output of a relational operator operation is always Boolean, either true or false. Now let's say I take a greater than b. This a greater than b will give you an output in the form of Boolean. So since our a value is 4 and b value is 5, this will be false. Similarly, we have a less than b, a equal to b. So here what you have to make a notice, there are two equal to symbols. That's the equality check. Double equal to. A single equal to is an assignment operator. That means the value of b will get assigned to a. What I mean to say is that if I type a equal to b, what happens is the value of b gets assigned to a. It does not check for the values. It directly assigns. So equal to is also an assignment operator. Right? I have mentioned here also. So be careful about that. That's the equality operator. Then we have the not equal to operator. Then we have a less than or equal to operator. And then a greater than or equal to operator. Even here in these two operators, not these two, basically these three, the order is important. You cannot have the exclamation mark after the equal to. This is wrong. Similarly, you cannot have greater than after the equal to. That is also wrong. Again, you cannot have less than symbol after the equal to. This is also wrong, right? Now let's see what the outputs are. In this case, again, a greater than b is false, a less than b is true, 4 is less than 5. A is equal to b is false because 4 is not equal to 5. Maybe we can have one more, just for checking, right? We can check if b is equal to b. We know that they will be equal. Maybe I can introduce a new variable, c equal to 5. So b equal to c. Just to see what the output is. Then a not equal to b will give again true because a is not equal to b. 4 is not equal to 5 and it will give true. A is less than equal to b. 4 is less than equal to 5 is true. A greater than equal to b. 4 greater than equal to 5 is false. Let's check the output. Yeah. So a greater than b is false. 4 is greater than 5 is false. Then we have 4 is less than 5 is true. Then we have 4 is equal to 5 is false. Then we have 5 is equal to 5 is true. Again, we have a not equal to b. 4 is not equal to 5. That is true. Then we have 4 less than equal to 5. That is true. And again, the last one is 4 greater than equal to 5, that is false. So these are the different relational operators that we have in Go. Sorry, this is supposed to be equal to. Now let's move on to the bitwise operators. Now bitwise operators, as I mentioned, are operators that work on binary value of a number. And to use bitwise operators, your data type should be int. So from my previous video, I think you should be able to derive that a equal to 4 means where a int equal to 4, right? And this would be where b int equal to 5. Now, when we are performing bitwise operations, let's see how the output is calculated. 4 and 5. Now, what is the binary value of 4? The binary value of 4 is 0100. Now, how did I get this? If you are interested to know, please let me know in the comments. I'll be sharing a different video for that. And then we have for 5, it will be 0101. Now, when we do a 4 and 5, what happens is each individual bits is made logical AND. That means 0 and 1. So basically 0 is considered as false in Go, 0 is false, and 1 is considered as true. Now what happens here is, in this case, 0 and 1 is supposed to be 0, because 0 true and false is false. 0 and 0 is supposed to be 1. Sorry, 0 and 0 is supposed to be 0, false and false. Then we have 1 and 1 is true, and we have 0 and 0, which will be 0. So the output should be 0100, that is again 4, right? Let's check it out. Yeah, so what you see here is a compile time issue, because in Go we are not supposed to have variables which are not used. If you see here, the compile time error says declared and not used A, declared and not used B. So we have A and B that are not used. So this is supposed to be A and B. If I run the program again, yeah, in this case you get the output as 4. That's what we had, 4. Now similarly, for the let's say what happens with the OR operator. Or, just like I mentioned before, how it works is just like logical or for bits. So 0 or 1, true or false will be 1, 0 or 0 will be 0, 1 or 1 will be 1, and 0 or 0 will be 0. So A or B, your output should be 0101, that is 5. Let's try and run the code. Yeah, you see the output is 5. So that was your bitwise OR operator. Now let us see what is the exclusive OR, the third bitwise operator that we have here. XOR, which stands for exclusive OR, takes in two operands. As you can see, how it works is when there are two operands for the bitwise XOR operator, if the operands are different, then you get a true value. If the operands are same, then you get a false value. So how it works is, for example, if you have the operands as 0 XOR 0, this will give you 0 because both the operands are same. Now let's say you have different operands, that is 1 XOR 0. This will give you 1, and same, sorry, 1, and same holds for 0 XOR 1, which should give you 1. Again, we have 1 XOR 1, which will give you 0. So based on this logic, let's try to evaluate what our A XOR B will result into. Now A value is 4, B value is 5. 0 and 1, the inputs are different. That means we will have 1. 0 and 0, the inputs are same, then we have 0. 1 and 1, the inputs are same, then we have 0. Again 0 and 0, the inputs are same, we will have 0. So the output should be 1. Now let's try and test it out. Yeah, you see 1 as the output. So that's how bitwise XOR operator works in Go. Now let's see how assignment operators works in Go. You already have seen the equal to assignment operator. Let's see what are these assignment operators. You have seen equal to, which is just to assign a value, and colon equal to, that is to declare and assign a value. Now let's just clear this out. B colon equal to 5. Now let's see what is A plus equal to 4 mean. Now this is a shorthand notation just to write A equal to A plus 4. So anything that comes behind equal to will be considered like this. That is A equal to A plus 4. So now if I do a println of A and fmt.println of B, I'll do an operation on B also. So for example, I can do B minus equal to 2. So this will translate into B equal to B minus 2. So the output should be A equal to A plus 4. That means the value of A is 4, A plus 4 is 8. And always the assignment happens from right to left. That means 4 plus 4 is evaluated and assigned back the value to A. So A will now have 8 and B after evaluation will be B equal to 5 minus 2, which is 3. So B will have 3. Let's run the program. Yeah. So you have 8 and 3 as your output. Even the division and the multiplication operator work in a similar fashion. You can try it out on your own and let me know if you have any questions. That's it. We'll be covering for today. This is Cron Coder signing off. See you in the next one.